Hi everybody, this is Mrs. Lehman. Welcome to class. Obviously I'm not here today and you have a substitute, so thank you to the substitute for following my plans and watching this video. I have a wonderful group of kids and I want to say thank you kids for being respectful and helpful while I'm out. You guys know the rules, procedures, and routines, so if you could please help out with anything necessary and honestly just, be respectful and quiet and take notes, and I will be very happy to hear that when I come back. So today we're going to work on this next lesson in our module, lesson 6, which is describing the center of a distribution using the mean, and that's on page 34. So if you could all open up to page 34 in your modules, that would be wonderful. Hopefully at this point you've already turned in your homework and you're ready to go with a pencil, and let's begin. So we talked about the different measures of centers of data sets. We've talked about lots of different data sets and we've seen examples of those, and we talked about the mode already, but there are some other measures of centers that we're going to learn. All right, so these include the mean and the median and of course the mode. All right, so we already know that the mode is the data value that occurs most frequently. All right, the median we'll talk about soon, but today we're going to focus on the mean, and this is not an adjective to describe your math teacher. This is a word that means the same thing as average. So you guys are familiar with averages because of obviously being in school, and you get an average every quarter. Pretty soon you'll get your 5-week average, and that is something that means we add all of the data, the numerical values, so add the data values, and then we divide by how many values we had. All right, so that's how you find the mean. You find the sum of the values, you add the data values. I'm going to put AKA find the sum of the data, and then you divide by how many numbers you had in your data set. All right, so we're going to go on to the next page where I believe I wrote the same thing, a lot neater. It says the mean, the average. Find the mean of a data set, add up all of the values, and then divide by the number of values in the data set. For example, let's say you got a 90, an 80, a 50, and a 100 on your homework. What is your homework average? So step number 1 is to take all of these data values that we have and add them up. So everyone right now, maybe in your bell ringer notebook or on a sheet of paper that you have nearby, go ahead and add up 90, 80, 50, and 100. All right, when you're done, you should get a total sum. If you take all of these numbers and you add them up, you will get a total of 320. So 320 is how many we had. That doesn't mean you have an average of 320. Our next step is to divide that number by how many grades you had in the grade book. So we had 1, 2, 3, 4 grades, right? So we're going to take 320 and divide it by 4. And when you do that, you guys obviously know 32 divided by 4 is 8. So we would have a grade of 80, right? So your homework average is an 80%. That 50 really got you there, right? So we talk a lot in math class about how a 0 is not really great for your average. It really is powerful in pulling those numbers down, as you can see. So this is the old school classic way of finding the average. You add your data, get the sum, divide by the number of values. Now, obviously it's 2019 and we have a unique way of doing things. So I'm going to show you what the module has in store for you, and hopefully a more fun way. I'm going to go to this next slide, and I did a little research online, and I Googled, actually, it wasn't a lot of research, it was Google. How many cats do Americans own on average? So I'm sure a lot of you own some cats, right? You can raise your hand if you own a cat. All right, I'm pretending I'm looking around the room, and there are kids with their hands up right now. Okay, hands down. And if we were to take all those numbers of cats, anyway, if you were to take all of those numbers of cats all of us own and add them up and divide by how many people owned cats or didn't own cats, actually, everyone, you would get 2.1, right? If we look at America as a whole country, okay? So on average, people own 2.1 cats. Now, obviously, you can't own a tenth of a cat, and if you do, you've got some issues. So what they did, though, when you have a large data set like that, you can't expect that you're going to land on a whole number, right? You're going to have a decimal going on from time to time. So we know it's usually 2 or maybe a little bit more than 2 cats, okay? So we're just going to round it to 2 and say typically people have the 2 cats. So I've got these fun people here. You're going to love this, guys. Okay, so we've got the Victorian man, it said in the picture search. He has 2 cats, right? He's got a fancy cane and a top hat and 2 cats, all right? The next one is an Egyptian lady. She has 4 cats. They loved cats and thought they were very special, so she had 4 cats. This third guy, you can see by that awful wrinkle in his brow and that frown on his face that he is upset. He has 0 cats, and I can understand why. All right, then we've got the cowgirl. She's always out doing cowgirl stuff, so she only has 1 cat. All right, and then we've got this lumberjack guy over here with the cool stockings on and the vest. He looks pretty rugged. I'm assuming he's a lumberjack and not an axe murderer, but anyway, he has 3 cats, all right? So what we need to do is find the average number of cats that each person owns. So it's going to come out to 2, but I'm going to just demonstrate this in a few different ways. So the first way we're going to do this is old school stuff, all right? So we have 2 cats here, we have 4 cats here, we have 0 cats here, 1 cat here, and 3 cats here. So we're going to add these all up. We're going to find the sum of our data. So 2 plus 4 is 6, 6 plus 0 is 6, 6 plus 1 is 7, 7 plus 3 is 10. So we know that there are 10 total cats, but that is amongst this guy, 1, this lady, 2, this miserable guy, 3, this happy cowgirl, 4, and this axe guy, I'll call him 5. All right, so we have 5 people. So 10 divided by 5 equals 2, and that's cats per person. All right, so we have 2 cats on average per person. All right, so another way of looking at this is pretty fancy. You're going to be impressed with this, kids. This is not how I learned to do this when I was in school, because it would be obnoxious if you had huge numbers to deal with. It works when we're talking about, you know, a handful of people here, but this is more to conceptually show you that means that the mean is, we're breaking it down to what would one person typically have, okay? So in this case, we already know the answer is 2. So let's think about this. We want to kind of level it out, all right? So we want to balance this out. So we know that this lady here to the left has 4 cats, okay? So she is going to give some to miserable man, okay? Now he has 2 cats. Hopefully he gets a little more happy here soon. So now Victorian man has 2 cats. This Cleopatra-looking lady has 2 cats. Miserable man will be happy soon. He has 2 cats. Cowgirl only has 1 cat, but Axeman is going to give her one of his cats. So now everybody, we have still 10 cats, but per per person, there are only 2 cats. Does that make sense? Hopefully. All right, so we're going to do the same thing now with puppies in a litter. So I, again, did some Googling to find out what is the average number of puppies in a litter. That means how many puppies do dogs have when they give birth. And it's quite a bit. The average number, we'll find out in a minute. So this should give us the correct number. And of course, that's going to vary on breed of dog, etc. But, all right, so we know this first dog here on the far left, dog A, we'll call it. This is dog B, dog C, and dog D. All right. So let's say dog A has 1, 2, 3, 3 times 4, 12 dogs are pictured here. Okay. So that not person, that's a dog. That dog has 12. That smart board's doing the thing again. All right. Let's see. Dog A has 12 puppies, right? Dog B only had 6 puppies. Dog C had a difficult time. That dog only had 2 puppies, and this dog D had 4 puppies. All right. So if we were to find the mean number, we would add this up. So everyone take a second and add that up. What's 12 plus 6 plus 2 plus 4? All right, hopefully you got a sum of 24 puppies, right? But that's not, one dog. That's amongst 4 different dogs. So we're going to divide that up for 4 dogs. And that would mean that we have 24 divided by 4 is 6 puppies per litter, right? So 6 puppies on average. Now, we'll go back to the thing we did with the cats, right? So we know it's 6 puppies, and that's what Google told me. Is Google ever wrong? Ha ha ha, just kidding. So anyway, I'm being sarcastic. What we're going to do is redistribute some of these puppies, all right? So we want to, we can't say like that dog C, that 2 dogs in a litter is typical, right? Because then we have dogs like dog A that had 12 puppies. That's crazy. And then dog B had 6 and D had 4. So it's really hard to say what's typical because these numbers are all over the place. So a good measure of center would be to find out on average how many puppies they have. So let's give some of these puppies from dog A to dog C. So there's 3 now over there. There's 4. All right, we got to spread some more out. All right, so let's give this dog C a few more puppies. And let's give dog D a few more puppies. Redistribute them. All right, so now all of these dogs have 6 puppies each. All right, so again, it's our way of kind of leveling it out and saying that if we had to talk about just one dog, how many would be typical? You divide up the number of puppies amongst the number of mother dogs. All right, so that's how you do that. Now let's go to the modules way of doing this, which is exactly what I did. All right, kind of redistributing the numbers. They kind of take you on a meandering trip here all over the place. So this first dot plot that you have in your module on page 33, is it 33 in yours? Let me double check quick. 34 actually in yours. Some things have changed. So it's page 34, and it shows the number of hours of sleep that kids had on a school night, and we talked about this same data set before. It was between 8 and 9 hours. That was pretty typical. 9 was the mode that had the highest frequency, and that was the measure of center we said before. We said that the average was 9, or I'm sorry, not the average. The mode was 9, okay? So 9 was the mode. Let me fix that. Let's see, is there a place to talk about this here? So this kind of rambles on, much like me. All right, let's see. Suppose that Michelle asked 10 of her classmates for the number of hours they usually sleep when there is school the next day. suppose they responded in hours, 8, 10, 8, 8, 11, 11, 9, 8, 10, and 7. How do you think Robert would organize his data? And what do you think Robert would say is the center of these 10 data points and why? And do you think his value is a good measure to use for the center? So I think they're getting at that one person may use the mode and one person may use the mean. So what we're going to do is, we already know that the mean is the average, right? And we know the mode is the one that occurs the most. So right here we have 1, 2, 3, 4 8s, right? And that's the most commonly occurring number. So the mode, we would say, is 8. Let's find the mean, okay? So let's take a minute and find the average, okay? So to find the average, we've got to add up all of these numbers, okay? So we know we have 1, 2, 3, 4 8s, right? So 4 times 8 is 32. We have a 10, so that's going to make that 42. Right, so we've taken care of these. We still have another 10, that would make that 52. We have 2 11s. 11 plus 11 is 22. I'm going to add that on there. So we're going to get 74 so far, and then we've got a 7, right? So we're going to add that, and we are going to get 81. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have 10 people that answered. So 81, write it down here, divided by 10. Move the decimal spot over one spot to divide by 10. So that's going to be 8.1. So the average is 8.1. Now in this case, the mode and the mean are pretty close to the same. All right, very, very close. Sometimes when we have data sets, the mean and the mode and the median can be quite a bit different. So we have to decide which measure of center best represents our data. In this case, they're both pretty close to the same, so I wouldn't say that one is really any better than the other. Let's move on to this. We are not doing this thing where we pass out 90 blocks. I'm going to go to the next page. This is example 2, and it says, suppose that Robert asked 5 6th graders how many pets each had. The responses were 2, 6, 2, 4, and 1. Robert showed the data with cubes as follows. So I actually had puppy pictures, you know, and cat pictures, but this guy's just got cubes. Lame. All right, so what we're going to do is essentially the same thing, right? So we've got all the numbers in order from least to greatest. We have a 1, 2 people with 2 pets. We have someone with 4 pets and 1 person with 6 pets. All right, so essentially what we're going to do is pretend we're taking this block, for example, and relocating it here. All right, and let's take this block and relocate it here. You can see where this would be very time consuming, right? It's kind of inefficient. All right, let's get rid of this one and put it over here. I relocated 3 so far, and there's still one more to go right here. I'll relocate that one right here on the left-hand side. All right, this is where that kind of crumbled. But anyway, there's 3 here, 3 here, 3 here, 3 here, and 3 here now, okay? So we just redistributed it so everyone had 3. So you can write that on your modules, all right, that we redistributed it. But another thing we could have done if we went old school on this is we would have said 1, 2, 2, 4, and what was this one, 6? All right, so we would add these numbers up. So we'd find the sum of the data, 1 plus 2 plus 2 plus 4 plus 6, and we would divide that by 1, 2, 3, 4, 5 people. All right, so when we find the sum of that, we're going to get 15 divided by 5. That means it's 3 pets on average per person. All right, so anyway, that is how you find the mean, right? You find the sum, divide by the number of values, all right? Here's a dot plot, and you can see if you look at this dot plot, there is not really it's not a real clear picture, right? We have people having as low as 1 pet. I'm sure there are people with 0 pets, but in this case, the lowest answer was 1, and then the highest answer was 6. You had one person who had 4, and then, you did have a mode of 2 here because 2 people, more than any other frequency, said that they had 2 pets. So anyway, that's really just difficult to see where one number stands out a lot. Okay, so we'd call this a very varied distribution, but we'll get into that later. Okay, so let's move on. All right, number of pets. So they've got the dot plot, and they've got the boxes to represent the same type of thing. All right, and then we can do that redistribution again, but I already did that on the page before. So they want you to redraw the boxes. So you probably don't have to make them 3D to save some time. So as long as you end up with a total of 15, well, there's 16 here. Nope, there's 15. Never mind, I was thinking this was 6. So anyway, this has 5, this has 4, this has 2, 2, and 2. So anyway, that is 15 boxes. Exercise 7A, draw the cubes representation that shows Robert's fair share. So if we had 15, we have to distribute them among 5 people. That means each person is going to get 3 of those boxes, which represent pets. All right, so if you're done, you have the same number total, 15. It's just redistributed in the fair share method. Okay, draw the dot plot that shows Robert's fair share step. I don't really know what they're getting at there. Okay, we are going to skip a lot of this at this point. So I think this is more confusing than it needs to be. You add all the numbers and divide by the number of numbers. If you can remember that, you're golden. All right, so let's do an example here and the problem set. And then I'm going to give you quite a bit of class time to get some homework done. So let's get this going. So a game was played where 10 tennis balls are tossed into a basket from a certain distance. Sounds like a hoot. The number of successful tosses for 6 students were 4, 1, 3, 2, 1, and 7. We're not drawing anything. Let's just find the mean of this set of numbers right here in your problem set for question 1. All right, so the first step, obviously, is to add up all the data. So we're going to take 4 plus 1 plus 3 plus 2 plus 1 plus 7, find the sum of the numbers, and divide by the number of numbers. So we have 1, 2, 3, 4, 5, 6 numbers. All right, so let's add this up. 4 plus 1 is 5. 5 plus 3 is 8. 8 plus 2 is 10. 10 plus 1 is 11. 11 plus 7 is 18. We're going to divide that by the 6 students, all right? And that means that on average, they got 3 tosses, successful tosses. Per student, right? On average, that's a mean value. All right. And that honestly took us, what, less than a minute? So that is the method that people use in real life. That is the method that we learned for many years before. Visually, it is nice to see this fair share method so you can kind of understand the concept of mean and where it comes from. But as far as actually using it to solve the problems, I think we're not going to do that. So let's look at the next one. All right, the number of pockets in the clothes worn by 4 students to school today is 4, 1, 3, and 6. Paige produces the following cube representation as she does the fair share process. Help her decide how to finish the process of 3, 3, and 5 cubes. So, well, this is going to be interesting. So, what we have to do is redistribute this, okay? So this, up to this point, they all have 3, right? You can see that. So we've got to get rid of this one and this one here. So we would have to share those 2 amongst the 4. So we'd actually have to chop it in half. This would get a half of 1, right? This would get a half of 1. This would get a half of 1. And we could keep a half there. And that would work out to 3.5 on average, okay? So it comes out to 3.5 or 3 1/2 pockets on average, or the mean number of pockets per kid. All right. And again, you could do this old school, 4 + 1 + 3 + 6 divided by, we have 4 data values. So you would first add 4 + 1 is 5, 5 + 3 is 8, 8 + 6 is 14 divided by 4. When you take 14 and divide it by 4, well, 4 goes into 14 3 times. That gives you 2 left over out of 4, and that simplifies to 3.5. All right, so any way you do it, you're going to end up with 3.5. Again, some people may see this equal distribution cube example a little more easily than the one on the left, but I think that's what you're going to see in life. Okay, suppose that the mean number of chocolate chips in 30 cookies is 14 chocolate chips. Interpret the mean number of chocolate chips in terms of fair share. All right, so that means each cookie would have 14 chocolate chips. Yeah, this is kind of getting weird. Okay, actually, I think at this point, I want to leave it at that. I don't want to like venture too deep into that, but maybe I can give you an example or 2 to try. Yeah, let's do that. In this spot where there's 4, let's do question 4. Let's make up a new problem. Okay, so where there is question 4, let's kind of cross that one out, and we'll just use this space here because this module does not have the note section that the others did. But let's pretend this is the number of cousins people have, okay? So we surveyed a group of 5 people, and they said that they had the following number of cousins. One person had 10 cousins, one person had 3 cousins, one person had 5 cousins, another person had 5 cousins, and another person, the last person, had only 2 cousins. All right, so let's find the average number of cousins. All right, so the first step is to add all of these numbers. So go ahead and add those up and then divide by the number of people we surveyed and see if you can find your answer. First thing you need to do is make sure you got the correct sum. In this case, it's 25. All right, so I'm seeing 10 plus 10 is 20. 3 plus 2 is 5, so 25. And we are going to divide that by the 5 people. So that means on average, we would say that there is 5 cousins. All right. So, okay, at this point, I'm going to have the substitute pass out the papers that I have left for you. It's all stuff that we've already worked on. It should be pretty easy. It's review. We'll pick up on doing this mean, median, mode stuff more when I'm back. The module kind of teaches it in an odd order. I'd like to teach them all kind of grouped together, but we're going to go from finding the mean actually to finding or discussing the variability of data sets, which essentially means how spread out our data sets. But that's going to be next. So right now we're just going to practice some old stuff with histograms, dot plots, etc. So thank you guys. Please be good and helpful. Get your homework done this weekend. Enjoy hopefully some nice weather, and I'll see you on Monday. Bye.